Okay, I got it to work. Verified it, everything. This is the error that contains 86% of the errors after doing one step of Newton-Raphson. I think I have to plot it. What should you do? I suppose it would be nice to have something where you can just... Nah, actually. I think I want to generate random cubics and then print the value, this formula, around the root, and at the same time do find the root with using Newton-Raphson and see what accuracy is that we can achieve. Pretty sure I have that code already, more or less. Well, excluding without having this formula in it. But I have something like probably this one. Let's see what that does. Okay, so this makes cubic polynomials here using coefficients that are just uniformly distributed between -10 and 10. Generate 1 million of those. And then for each this is just printing the number of iterations it takes. It's not exactly what I wanted. There was something else, sorry, maybe this one, Haley iterations. Just run it, see what it looks like, what I want. Nope, not. I guess I'll just run everything. It's been a while, so I just don't know how they... Oh, that's not it. There's a certain graph that I want to see back. I must say this is interesting. I mean, at least it allows me to generate random cubics, more or less. Well, not totally random. They always have 3 roots. So if at the same time I would draw the error in the same graph, that maybe could give some insight. But Yeah, so this is also not it. Close. Yeah. So this program generates random cubics and then stops when it finds one that has a where there is a problem to find the root very accurately. And then I hoped to visually recognize what kind of cubics those are. Oh, no, it takes a long time. Yeah, well, whatever. That's also not it. Random cubics 2. So this is also not it. It's even a previous version. I think it's not part of this test suite. It's not drawing anything. I don't think that's it. I have to go to another test suite, I'm afraid. Maybe. Blab switch profile to YouTube. It's a bit bigger font. Source. Tests. Nope. Oh, I'm in machine learning. Sorry, I have to go to the Cairo window. Guess tests. So maybe one of these. Oh my god, also so many. Goddammit. Maximum annoying. Can't find it. So it was a program that draws, I think, a double logarithmic graph And it shows how it approaches a root using Newton-Raphson or Haley's method maybe. So we do have to calculate the real root, and I'm using MP-real for that. So at the very least, it's a program that uses MP-real. So I do grep source MP-real, and we see nothing. Oh, that's interesting. Make C tags, regs, and still nothing. Shocked. What the hell? It just made this one, so why is it not using it? That is using build dir tags. Oh, wait a minute, that was C tags. Never mind, I'm an idiot again. What was I trying to do? RNGS, yeah. So, which DS? It's just using this. Yeah, that makes a little sense that it doesn't work. What the hell? Let's do it manually here. Grep MP-real. Nothing, indeed, nothing. Huh? Hello, Clement. So maybe I did move all MP-reals over to math. There are stuff. There's stuff here, so not that much. So anyway, the program that I'm looking for, I'm pretty sure must include MP-real, like that. Should be this one, I think. Haley iterations. Ah, no, that's something else. Yeah. Previous, I didn't wait long enough to see this, but it's not what I'm looking for. Can't close the bloody thing. Yeah, that should be enough. Execute and grab that on every fucking file. So, duplication. There's a duplication. I bet I moved it from here to there, and then I never removed it here. But then why does GS not work? It should even work from here. both Cairo tests and the math is not being shown. Oh, math is being shown. That's the one. What is this? Source convergence tests. That is that one. Missing this one. Right. So not even a difference here. Maybe my Cairo window wasn't updated. It was. I'm just going to remove it then. I should remove it here, I think. So it was removed, but not from here. What? So maybe I didn't push this. Ah, there it is. Deleted. Yeah. Yeah, it's just it commit everything. Moved to math test suite. Git push. Yeah, so yeah, my guess would be that it has to be one of these. Let's just look at all of them because it's not that much. Convergence test. I mean, that really looks like that's what I am looking for. And I'm not sure if this was using quick graph. This is very possible. Quick graph. Maximum relative error in initial guess still resulting in 2 iterations, so this is definitely not it. Next. A root of polynomial. Relative error of approximation. That's too small. That's also not it. Probability distribution is also not. Print roots. Log graph. Print roots. Yeah, this thing is not even making a graph, right? Yeah, that's why I didn't see the graph, I think. I have to pass the cubic here. Allow neuron. I don't know how I have to pass it though. See if we can figure that out. Parses the string. Parses the inputs. I don't know, let's just try something, I guess. Print roots. So, probably multiplication. Duplicate a term with exponent 0. Okay. Maybe no multiplication sign here, thing here. Expect a leading plus or minus before 2. I'm doing it wrong. What? How? How's this bloody thing parsing this? Just use 4. That is the graph that I want. Yep. So I now only have to figure out how to input the cubic. That's not working. Maybe I have to start with X up front. My God. I'm gonna ask it bloody AI. It's full of bullshit now. This also has only one thing with exponent 2, and one with exponent 1, and one with exponent 0. There is no duplicate. Okay, let's just debug it then. What a waste of time. What the hell is this? printing the contents of some vector. Match 2 was 1.5, so we converted that to value. So the input was this, and we got coefficient of the first thing. Okay. So far so good, I would say. Value multiplied with sign. If symbol empty, what is symbol? Totally empty. Match 8. Match 8 is indeed the symbol. Yay. Print symbol. Symbol is x. Now I have to agree with that. The exponent. If the symbol is empty, the exponent is 0. And otherwise, if the length of 10 is 0, then it is 1, but we have a 2. And otherwise it is the first digit of 10 minus 0. So yeah, this is going to be 2, right? Next, print exponent 2. So it fits in Why is this coefficient size 4? 4 times 0. Yeah, okay, whatever. I think I'll just... So coefficients exponent is 0, so we don't skip that, and now we assign it. So the coefficients of that exponent becomes value. So now coefficients is that, meaning we have at most a cubic, where we have 0 times x to the power 3 and 1.5 times x squared. I don't see any problem yet. Next, now you should get the next thing that matches in that horrible regular expression. Match. Okay, so the next thing is plus 2x. Well, I would say yes. Okay, that's the leading thing. 2 is the coefficient, 3 is nobody knows. 4, 5, it's very empty. 6, 7, 8, 9, 10. So the sign is, if the length of 1 is 1, yes. If it is a minus, it's minus 1, otherwise it's 1. Well, it is a plus, so your sign should become 1. Print sign. If the sign is 1 and not the first, well, I think this is not the first one, so now we have false here, so this is okay. And then match 1 is 0, or match 1 is unequal plus. So this is not going to be true then. If it was true, then it would have printed, hey, expected leading plus or minus. Okay, SS. We write match 2, which is 2 to SS, and then to value. So value now is 2. And I have I forgot the input again. I just print it here, I guess. Print input. So now we have this, the 2. Still 2. Nope, we do have the symbol already. If match 8 length is larger than 0, what is 8? I think that just means, do we have a symbol at all? So yes. The symbol is unequal 8, then we have a problem as well. Mismatching symbols, so that is also not the case. Exponent is, if the symbol is empty, nope. If the match of 10 is empty, then it is 1. No, match 10 is empty. So the exponent is 1. Print exponent 1. Next. And the coefficients is still what it was. So it's saying, so coefficient 1 is 0. So it's not unequal 0. Which means that, yeah, I did a next instead of a list, but I did not print this, and just filled in the exponent x to the power 1 is 2, the coefficient of that. Then we get the next regular expression thing. So far everything works, so really. Now this function used to work, so. And then suddenly, well, while you don't use it for a while, it doesn't work anymore. Really strange. Now that was the last part of input. That is the last part. And this should be filled in as under exponent 0. We should get a -3 in here, and then we're done. How can this go wrong? No. Let's print the sign. The sign is now negative. And the value is 3. It just works. I'm not even checking it anymore. Value is -3. The symbol matches. And here we have Okay, that's not correct. And that's why it goes wrong. We don't have a symbol here, so we should have gotten 0, but symbol is still set apparently to x. Should already have entered here then. Huh? Okay, so the constant must be up front, otherwise symbol is already initialized. Then here we have the well, it's a quadratic. Yeah, I knew we need a cubic. Worse, we need a problematic cubic. So this is how to do it. Yes, seems to work. And I need a random cubic that is problematic. No, maybe this one. Let's try this one. So now I have to copy this. That's basically the title. This one. Copy. Okay, so there it is again. This thing is almost flat where the root is. The green line shows me the root. And the derivative there is yeah, 0-ish. And then the problem is that, or well, you see that that there is a problem rather, that the noise starts around -14. Well, if you take a sensible thing, you get all the way down to -16. This being a logarithmic scale, that means that it is like a factor of 100 less accurate than these things are annoying. You have to ignore them. Just the lines to 0, 0 there. Can I still remember what exactly this was all? Now horizontal we have the log 10 of x minus the root. So the closer we go, the closer we access to the root, the actual root, the lower this number is. So this means we have a difference with the root of 10 to the power minus 14. But yeah, that's an absolute difference. I'm not even sure if this label is correct then. You more expected to talk about the relative error here. The best you can get is like 2 times 10 to the power minus 16. That is the machine epsilon of a double. So now certain cubics will have will approach this root, as it were, and then get saturated due to errors around -14 or even worse. And some will have the line here, that the slope is always the same. And they will end up at -16. For example, this was a problematic one. What happens if I just change the cubic to, I don't know, slightly? Let's make this a 2 instead of a 3. You know, instantly it approaches the point here, crosses. It's more like, I think the -14 is always the same here. I don't even know what this is, but so where it crosses this line here, that is the error, and that is more or less the machine epsilon. So this is just very accurate. And it should be, if you see how the cubic looks like. It just yanks through the y = 0 here. So the root is super easy to calculate, super cleanly to calculate with Newton-Raphson, because the derivative is not 0 in anything, or anything like that. So I think that I want this program to print my calculation for the expected floating point round of error. And then see if indeed that is much smaller now for this cubic than for the other cubic. For a start. Got to start somewhere. So I have my program, print roots, and it plots stuff, and then I want to print, why is this a loop? It's just a try actually, but then there comes a loop as well. Here's a loop. Oh, because I have a slider, yeah. What is my slider doing? Xn value. I always think that I write a lot of comments, but then you look at it a few months later and it turned out to be no comments whatsoever. What the hell is Xn? Arg. It's like at the moment you write this, it's 100% clear. You just know what Xn is. And then you forget to add a comment to explain what it is. I know. Haha, I even understand it. Xn as in the nth iteration of Haley, I think. This is using Haley, right? So we have an Xn, and then we're going to calculate Xn plus 1 from that with a single Haley step. Yeah, Xn plus 1. Let's see what it exactly does. Okay, here we see it. So I pre-calculated the root with high accuracy. And the slider value is used as the exponent of 10 So you can have 10 to the power minus 14, 10 to the power minus 10, say. And then we use that, and that is what is horizontally displayed. That's that minus 16 to minus 14 stuff. So that is added to 1, so it is unitless. And I multiplied with the actual root value. So yes. And then we do a step here, next offset. So I know the exact root and we know the offset, which means that we know xn without passing it, because xn is just the root plus, both those two give us the xn. Yeah? And the coefficients are the polynomial that we want to find the root for. Well, we know the root, but we just pretend we don't. So whether or not we use Haley's method or Newton-Raphson depends on what this function is implementing. Next offset. Okay, that's Haley's method. Next offset is using the actual root here with the high precision. MP real and multi-precision real is like infinite precision, basically. Coefficients are also infinite precision. So the whole thing here is calculated exactly, without any round-off errors. You would have to wonder where the noise comes in then. What else is the difference between these two? Oh, there's two different plots, I think. No. Well, no. Well, it should be. Okay, let's run the program. So use this one again. See, it draws a line here. That would be one of those lines in this graph, but it's not super interesting. This one is more interesting. So yeah, okay. So this now we have xn is set to -2, which means that 10 to the power -2 is 100th. So plus 1 is 1.01. So we are 1% relatively off of the real root, and that is plotted in this graph at the -2. So this line here means that we are 1% larger than the actual root. The actual root is infinitely far to the left. So this is at a relative error of 10 thousandths, 1 millionth, 10 to the power minus 12. Yes, I can't pronounce that. Very, very accurate. And then after one Haley step, we end up here, the red line. So from here we go to there, and then the next step we would go from here to, then I have to put the green line here, which is a little bit larger than -5. So let's put the slider down to no, where it was. So we go from 1% off to, I don't know, 100 thousandths off. And then the next step, it's already almost as accurate as you can get. However, I mean, the accuracy with the Haley's method, accuracy is tripling every time. So you would expect the -2 maybe to go to -6. Or am I wrong here? But yeah, anyway, if I put it really at -5, let's put it at -4 here. So -4 goes to, yeah, also not -12. But it is the expected point. The blue thing is also plotting something. I don't know what, but it is, the dip here is exactly where you expect it to end up. So there's nothing weird going on. This is where you expect to end up. But so then now xn becomes xn plus 1. So I should put this thing here. Let's. I'm going to put it at -10. Let's say we started here at -3.75. Then the next iteration is at -10. And then the next iteration is at, I'm setting the green one at -10 now. Oh, sorry, the red one, the red line is the theoretical best thing. So that just went completely off the graph now. But what we end up with is this blue dip here. So it doesn't get any more accurate than this one. This is the what you will end up with. You just can't get past this noise thingy. Do you see that? There's the red one. So if you are as accurate as 1 millionth, then theoretically you would jump all the way here, and therefore, because you can't get this accurate, it just doesn't even fit in a double, we will end up somewhere here. And it just is noisy because it depends on the least significant bits and all kinds of round off errors where exactly end up. So if I move this back and forth a little bit, you see this blue thing jump back and forth randomly. Sometimes it's by pure coincidence super accurate, but then sometimes it's all the way over here even, and then you are very inaccurate. So it's more accurate, and then it goes up a bit, down, go bang. So if you by coincidence, I mean, this is still the same cubic, the same cubic, the same root, everything. But by coincidence, you would find this point here, which is far from the real root, and you do one Haley step there, then you get all the way here, which is pretty damn as accurate as you can fit in a double in terms of this root. But if here you were a little bit more accurate, then you might as well end up here, which is much less accurate. Right. So I wrote a program that calculates the formula for a given cubic, giving us the a kind of an expected error. So the cubic doesn't change, even though I changed the initial value that we put into Haley's method. That means, I think, we should be able to draw a line, a vertical line here somewhere, that corresponds to the calculated error. So I calculate the error, I convert that back to this horizontal scale, and then we draw the line. And then it would be nice if that line would always be, let's say, yeah, well, to the right of the noise. Let's say maybe here, where my mouse is. And then that would be the expected error. And it can by coincidence be more accurate because, yeah, it's distributed around that mean. So if it is exactly on top of the root, it's infinitely accurate, of course. It can just happen. But yeah, that this is so accurate, it doesn't mean anything. It's just coincidence. You have to look at the highest peak, the highest value here. So you do a little bit like this, and you see that it is minus 14. Yeah, it's not often not often less accurate than 10 to the power minus 40. So maybe the vertical line should be plotted like here. Now, let's do it. But this is Haley's method. So I need to implement that. We might as well go the whole way now. Is this problem? No, it's this one. This is Newton epsilons. To change that to Haley's epsilon then. Shall I? I can add it to this program. I have a class in here that this FA class tracks the floating point errors. So I can use that. I was curious what it thinks of it. Haley's method, yeah. Stupid Copilot. Okay. Dun, 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 dun. Haley's method. Starting to get annoying that the Copilot fills in stuff while I want to think. It's not really wrong there though, except I already have that. I have an approximation for f and an approximation for df. Well, what we do need is the second derivative as well. So let's construct a second derivative. Now let's see if Copilot is smart enough to know how to do that. 6, it just doing it? No, well, it starts with epsilon 9, but it's because I don't have enough epsilons. No, epsilon 9 is nonsense. But I'm interested in, is this 6 correct? 4c2 plus 6c3, what is it gonna do? Actually it's correct. Yeah, this is it. But we need more epsilons. How can we make more epsilons? These are 1, 2, 3, 4 more. This starts at 6 here. Why? I already used the 6 for the first derivative. Yeah. Yeah. Oops. Top. Return. E. Otherwise it doesn't go. Top. Return. E. Top. Return. Top. Return. No, it's going. Okay, let's just add a few. How about 20? Oops. Need more though. $20 of those. I'm not sure, but I think that's all. Oh yeah, no, it's not. No, I have 21 actually. 21 number of epsilons. You think Copilot knew that as well? Is? Nope, still thinks we're at 12. No. See if everything still works. Neutron epsilons. Core dump. I think I forgot to. No, I didn't. What? Oh, we have a list somewhere. An array that is initialized with the wrong size initializer now. But where? It doesn't tell you. Well, there's a core dump, but nobody gets this. Do I really have to run this in a debugger to find where that is? Core dump. Yeah, to be expected. 212. 215. I really got lazy here, I remember that. Oh, that's... You can be lazy these days. Copilot. Go! Okay, it still works. So now I have plenty of new epsilons. And then, of course, you want to use those new epsilons here. Yeah, I think I'm gonna start off with whatever we did. Well, a 10, say. 10, 11, 12, 13 then here. It's a bit in the wrong order, but don't feel like reversing them at this point. Okay, let's print those. Just have a quick check. So the second derivative is 2 times C2 plus 4 times C2x. I don't think so. No. What is the second derivative? The second derivative is, of course, the derivative of the first derivative. This is my function, yes. And then the first derivative is C1 plus 2 times C2x. That's over here, plus 3 times C3x squared. So this is the first derivative. And then the second derivative is going to be 2 times C2 plus 6 times C3x. 2 times C2 plus, and then we completely went wrong. I think it's my fault. Well, it's probably a Copilot's fault, but I copied it. I believed it. Yeah, this is, we first have to multiply the thing with x. So this is 6c3 plus times x, so simply this. And then the derivative is C2, I think. C2 plus 6 times, no, there was 2 times C2 it was. No, I don't want to introduce a new epsilon for multiplication with a constant for unclear reasons. So we should do 6 times C3. And then this multiplication here gets the epsilon. (6c3x) and then 2c2 plus 6c3x. With a new epsilon for this plus. Round off that operation. Yeah, no, that looks good. Looks good. And then the round-off errors are this, where these can be seen as uniformly distributed between plus or minus the machine epsilon. And now I have to refresh my memory about how Haley's method works, but let's just look at the code. I was using print words. Yeah. Next offset here. So Qx calls evaluate on xn, which is it shouldn't be symbolic, is it? It's the cubic polynomial. Yeah, so this is how we calculate the cubic. You just multiply it with x and then add something, multiply again with x, add something, multiply again with x and then add something. That's how I did my FA. And the derivative also works the same way, right? That's, yeah. I need half the second derivative, probably. Now I think about it. Yeah, need half that. So in the end, we are going to calculate the xn plus 1 this way. Just copy, oops. Just copy this for now, and then oh, wait a minute, let's copy it with the mouse, and then I'm gonna go to the neutron epsilons, paste it in here. And nobody needs to know here what the type is. And evaluate is actually the f. And the derivative, then no, let's call that df. Half the second derivative. Okay, so we do that. Construct half times second derivative. So I want to divide this by 2. So we can divide this by 2. And this is then 3. But can I not reuse this value? 3 times C3 times x. You might already have calculated it. In which case the epsilon is of course the same epsilon. Yep, already have that. 3 times C3x. Maybe the C2 plus that is also already known. No, it's not known. Probably not. Wait a minute, what am I doing? Oh, damn it. I thought it was the same name. No, it's this, that's what the name is. Now I have 2 times C2 plus 3C3x. And here we have just a single C2. Oh well. I'll give it its own epsilon. C2 plus 3 times C3x. And then the same epsilon 9 is being used. It also pops up here. Looks a bit different. Nou ja, it moves in mysterious ways. C++. think this is correct. Half times the second derivative. Yeah, okay. Next, we calculate. They're doing a lot of calculations here, all in one line. Well, that one's last, of course. The order is not really determined, what we don't care. It's just a numbering of the epsilons. So let's begin somewhere. I'm going to do square this or something. Okay, so FA square. The square of that is, oh wait a minute, you have to do that like that. And then it comes up with something that is bullshit. Or is it not? See, the dqx is actually df. And it fills that in. df times df. This is like scary intelligence, as it were. Doesn't it is a bit afraid to reuse epsilon 11, but I think I'm gonna do that. That looks correct. Do you seriously mean that Copilot learned from my comment what dqx is? And then, nah, yeah, whatever. Yeah, and this is bullshit. This is bullshit. It's doing too much at once. Let's do the multiplication first. So I'm gonna do this multiplication. Let's do that as q times that. And now it's right again. Because qx is fa and dqx is dfa. And then multiplied. Yep. So now we have this one and that one, and we also want to have this one now. So it's going too fast again. Yeah, now it's correct again. Play chess. Yeah, it's 9 PM, a bit too early to play chess now. Qx, that is FA, half ddqx, that is that thing, which I just have calculated, where? Oh, there's this thing, which is the half second derivative, which is this thing. So yeah, that's correct. It's still doing things too fast. Why? It keeps doing that. First you have to calculate the difference. Minus, fill it in. It fills it in. Now it's okay. Finally. Okay, well, let's check it anyway. So this should be the difference between the square and the thing that we just calculated, yeah, with the next epsilon. And then here the step is then the whole thing. So now we do that part, which is this, divided by the thing that we just calculated with the next epsilon. And then, yeah, we still get that one. Oops. FA. Nobody knows what is happening. FA. Yeah, let's call it that. Is x minus step. Brilliant. Let me print that. And it doesn't compile. I blame Copilot. I totally blame invalid operands of binary expression. I cannot subtract two FAs. Okay, that's definitely my fault. But why? Are you telling me I never have subtracted two FAs before? Operator star, operator plus, operator minus, but you subtract an expression. Division, adding another FA, negation, friend to add again an expression. Wait a minute. Oh no, this expression minus FA. Yeah, well, I guess I just didn't add it. Let's add the plus operator. Or we'll look for the plus operator. So this is the plus operator. Add an FA to an FA. And we need that. Okay, I'm gonna do tab to see what it filled in. Yeah, it's not what I wanted. It's a bit too much code duplication for my taste. I'm just going to return. Yeah, exactly that. On second thought, it understood. So now we just reuse the plus operator. Negation we have. Negation here. Negation is also pretty big, but okay, we already had that anyway, so. Yeah, this is how it is. That is negation. And now we have a big formula. Oh, yeah, that's the error. The error is no. The error becomes. The error is even way bigger. The step here. The step is this, and then the error is that. Oh my god. Well, that is expressed in all the epsilons, 16 epsilons in total, apparently. So now, to get my error formula, you have to print the error of that. No, just one page. This is the error. Plus or minus, and then we have to calculate this. Okay. Nobody wants to type that in, which is annoying, because it means that I have to generate it every time, which means I have to, at the very least, make my FA class a header, so I can use it from two different programs. Yeah, it's probably the thing that we have to do. So I'm having a math test suit here, and I want to share that header with another test in the same directory. Yeah, let's just put it in the same directory then. Already have one here, another header. Let's commit what I have now. KIRO window, git status. Oh, just new commits. I never did this. You didn't see me do that. I never streamed, by the way. The point where I finished my derivation for how to calculate, how to collapse all those epsilons into the machine epsilon. And I'm not going to, I'm just going to show that shortly, so that if anyone really wants to know that, they can study it by stopping the video, I hope. Let's see, I did paste that here, I think. I think it starts here. How can I blow up that font a bit? No, just, huh? Never mind. Maybe not Discord. No, okay, let's use this then. So if you read this, and I'll just show it and then continue. So you have to, I don't know, stop the video, I guess, to read it. Now, also, Claude thinks it was a fascinating mathematical analysis, so. And it does have a nice summary here, I have to admit. Nou ja, and so on. Now my window is larger than OBS. I think it's still cut across then. think it did. Bottom line, turned out that you can just so we calculated this. Step is exact value and then something times epsilon 0. This is epsilon 1, or is epsilon 0? Yeah, it's epsilon 0. And then sometimes something times epsilon 1, and so on. And then you'll get with an error less than 1.5% if you just square everything in front of every epsilon and then sum it. And then take the square root and then multiply that with 0.8667 something empirical value. Which then only works if you pretend that you're only interested in exactly that amount, namely 68.6% falling within that range, which is then equal for the normal distribution as well as for a uniform distribution, and therefore it works really accurately. So I did that here. I took all those coefficients before every epsilon and then squared them and added them, and well, that's this. This is just the sum of the squares. So I'd still have to take the square root and multiply it with some factor, but okay. Let's see what I'm doing here. This is neutron epsilons, okay. Yeah, I did a lot of work on this off stream. The main problem wasn't the division here. So I put many hours into fixing the division operator. And when everything finally worked, I started streaming again. It's just the committees, right? Work in progress. Yeah. I'll push it even. Maybe you should add the clank format as well. Why not? Okay, all clean. And then I wanted to split up FA, maybe I should rename it to something. I mean, come on, abbreviations. What does it do? It's a representation of an expression in symbolic form in terms of the expression, the exact mathematical value of the expression, or just the mathematical expression, I guess, formula. Plus expressions that have to be multiplied with some epsilon. but it only keeps the first order approximation of that. So every term with 2 epsilon factors has been neglected. So FA stands for first order approximation. But yeah, of what? I'm going to call it errors or error. I should make it even longer probably, like tracking object, floating point around of error tracking object. But yeah, some, I mean, you could also say that by the time I reach error and I still didn't fall asleep, I probably did recognize what it is about. Well, if I just call it FA, then in 2 weeks I will have no idea what it is about anymore. And I opened the wrong thing. Let's see in here. Yeah, this type, epsilon index type, is being used in this array, and is it being used outside class? Yeah, but I'm gonna move it inside class anyway. I think it is something that belongs inside class, isn't it? Doesn't it? Every using inside a class must be public. It should be public. There's no reason not to make it public. Plus, I need it to be public because I'm going to use it. Now we need an epsilon index category. Might as well use now this class. So any type is okay as long as it's a unique type. So we don't need that anymore. That is if I don't use it anywhere else, and I'm not. But let's check that. No. Now but this one into number of Actually, before I do that, let's fix the code again to anything from here till the end. If that has this in it, then you have to change that with uh-oh, now I have to type it again. Really? Floating point round off error double colon. It's completely beyond me why updating this and not this. Why? Did I only select huh? What? No, I did do everything. Did do everything, didn't it? Yep. Yeah, you might also say this whole I have to initialize this is a bit super annoying, huh? Super annoying. I mean, having to deal with anything until you start to do the until you start to do this. I think this should be the first line. Everything else should already be inside that clause somehow. Or, well, at the very least, I think as well, this thing is so long that we don't like it. So I'm gonna do inside main using FA is that, and then change it back to FA. It is probably a better idea here. And now it's a tiny little bit more reasonable to have all of this. Just a tiny little bit. Is this F and this DF and this G even used below this point? I don't think so. It is used. DF squared. I don't think the G is being used, is it? Nope. Just delete this and then we move this down to where it is first used. Where's my DF now? Yeah. Just need it for the verification. Okay, problem with number of epsilons. Really, that also should be inside here. So I'm gonna do. Yeah, that must be static then. So static const expression. Okay, so it's only used here, which is an array of symbol pointers. That's also so epsilon dependent. Really, this should be part of the class. So it's creating epsilons, which are pointers then. And I'm using that for what? I'm using it to loop over it here, but also only to fill variables. No, I need to pass it to expand, but if it is part of the class and it is static, then I don't have to pass it here. Definitely looks like if this is part of the class, that would be okay, and unless we need variables. It's using variables already. What? That was here. I'm assigning. Oh, I'm setting all the epsilons to 0 here. So yeah, maybe then the question is variables. Should variables be part of the class? I'm afraid not, because my variables contain all variables. Also the ones that I work with here in main only. It's a bit of a mess. Yeah, I'm not going to put a lot of time into making this clean, because it's just a test for a test suite. So as long as it's more or less split up into a header file, I'm happy. So yeah. Now normally you would make this a template parameter. Maybe I shouldn't make a template parameter anyway. I'm making it a header anyway, right? And everything is already in line. I'm not really a fan of templates, I must say. Not unless you really need them. But if I use this class in different programs, then each program will have its own number of epsilons. So then this would become the maximum number of epsilons. And I can set it to 21, and then it would work till 21, and then someday I will need 22 of them, and then I need to edit my header, which is also not something that you really want. Okay, let's make it a template. But now, no, that's good. That's good. That's good enough. Okay. Well, that means that this thing is now a template, of course. So we have to change all occurrences outside the class with well, that should do it then. Unless I use number of epsilons. No, I still have them. Already made that a global const expression now. I think it's time to remove the class now. This belongs to it. Yeah, so the print off. Let's even remove the has print on. So. Two, 6, 8. So let's begin here. Delete. Next. Oh, there's only one file to edit. What else do we need? Array index. And that is just utils array. Symbolic. Symbolic. Epsilon index types are defined there. No, that might have been it. It's just the epsilon index type and an array and a symbolic, I think, yeah. Well, and print on. Good. Then, of course, you need to include that in this file. Yeah, since this X already has the number of epsilons, I probably should move that to the top. Oops, so it's a bit more clear. We have 21 epsilons and therefore we have 21 of these. You can argue that I should include the array. Just deleted it because utils array already includes that. And utils array is now included by the header that I just added, floating point around variable. Yeah. And this thing is apparently using libcwd or debug output, but I'm using a standard shout all over the place. Now I can do that in this test program, but definitely not in the header then. If that has any output at all. Cannot be for the first one. There's only one file now suddenly, what? And no, we don't. There's two files. Got completely confused. Standard cout. Nope, we have the not standard cout. Very good. And then hopefully it compiles. It doesn't. Almost nothing. What? Yeah, I should have just... I missed that one. To start with this, that would be algorithm, right? Algorithm needed for standard ranges, count if. To move that, should have moved that one too. And then we have regard for all declarations. Don't have no type there. Whoops. 21 looks like an integer to me. Now it worked. But yeah, I must say I'm still highly annoyed by this whole pre-initialization that apparently is needed here. This can be moved further at the top. Variables static cost variables v. The v runs from 0 till the number of variables. The number of variables is simply the number in this enum class. So what I really am doing here is running over all the enums here. I just there has to be that there must be a better way to run over all enums. Thought I had something here. Enum iterator, is that not what I'm looking for? It's just enums, not enum classes. Choose a contiguous range of enum values, each one larger than the previous value. We have one larger than the previous value. Which is the case for foo utils enum iterator first last. Okay, like that. If it works for an enum class, that is. So we try that. Yeah, the first one. First one is C0, but actually it's not even clear if it is C0. Probably it is C0, but it's doing for each variable declare variable. Okay, it's just this the thing as it is, so that would be C0. And then last is inclusive, or is it one beyond the end? Inclusive. So last is still printed. Beyond last not, probably. So that then, in that case, we would have to use E20 or something. Yeah, E20. No, X, actually. X is at the end, in this case. I'm not sure now if I'm super happy with this, all of this. But okay. So if this works for an enum class and not just for enums, then I think this would be the syntax. And then yeah, foo must be variable, which then means that it just takes care of this casting, so I don't need that anymore. Let's see if that compiles. Nope. Oh, well, it would maybe compile if I added the header. Utils enum iterator. It is not smart. It is not being smart now. Const expression variable cannot have non-literal type. Const enum variable. To be honest, I have no idea what a non-literal type is. Safe to say that it doesn't work with enum classes. Incomplete type. Aha, an incomplete type is probably not is a non-literal type. Const enum iterator variables variable is not a literal type. Wait a minute. Note, incomplete type blah 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 is not a literal. Okay, so if it's incomplete, then it's not literal. Whatever. Why is it incomplete? Definition of is not complete until closing. Oh. Okay. Error use of undeclared. Yeah, the blah. Okay, so we are using enum iterator before the class is defined. And that is here. No, that was a lot of decoding the error, but that's pretty annoying. So this class is not defined until the closing brace, therefore we can't use it here. What the heck? Unacceptable. Okay, let's do it the dot way. I'm just removing the const expression. I don't know why it's suddenly complaining about this, but since it's not a const expression, we have to instantiate it. But since it's a template, we just do that after the class in the header, and which then requires the same type template stuff. So what are we talking about here? This is a template taking all these things: t, comma, begin, comma, last, and then send is a member of that class. By pure coincidence, the same class. Oh, wait a minute, I can't define it here now. Just have to declare it. Still, this didn't get solved. Error use of undeclared identifier v. Oh. Oh. Yeah, okay. So now we have to get the underlying thingy. Wait a minute, variables. Yeah, okay, so because it v, well, v used to be an int, we can't just use variable, this one, because that's an enum clause, and an enum clause, unlike an enum, does not want to be converted to or from an int. unless you cast it. So I could add a cast here, but it is at least as dirty as it was, if not more dirty. So we had a cast, and now we still have a cast. Plus, I would rather use my own array index system, where this has a type that is only accepted by this type, this array type here. But then it wouldn't be variables, it would be some index type that belongs to variables. But that's okay, because variables itself has exactly this size, right? So if you look at variables, oh wait a minute, variables is not an array. What am I talking about? This variable, sorry. This variables here is an array of size number of variables, which is defined again by exactly the number of variables in my enum class. So I think the correct solution here is to use utils array instead. I think I still need my enum class. I'm not even sure, but let's have a look where the variables are being used. For the count, for the name, the class symbol, that I get name from variables. What the hell is variables name here? Oh, this name. That's upset. That was stupid. Yeah. No, this is an enum class, so you have to prefix all the element names with variables colon. So we pass here one of those enums, and then you have to do it like that. And this is a cast. Oh, I can use two index. That's what I'm using right now. Let's stick to that instead of revamping everything to utils array then. Yeah, well, okay. I could theoretically then I could make this a utils array and then get rid of this two index. Maybe shall I do it? Okay, I'm gonna do it. I'm gonna do it anyway. So that's still the question: do we need the enum class at all? What is it being used for? Here I'm just typing in variable e0 and then immediately converting it to an index. Might as well store the index in the enums. Yeah, again. So basically it's not being used, except as a human typable string that I can now type epsilon 0 or e0 with variables in front of it, otherwise you would get confused with everything else. But in all cases I even convert it to an index and an int index. Let's rewrite this. On the other hand, why would I not need this? I mean, I might want to refer to this, no? I mean, I am referring to it. I'm referring to, let's say, C0, C1, C2, C3, and X. Yeah, here, or not here then, but like here. And these things are declared. I mean, this object and this object, etc., is declared by this, which runs over all my variables by means of that dirty macro, and for each of them does declare symbol, which then creates me a symbolic symbol const reference with that name. Which uses variables, which is, I think, a symbolic symbol const pointer. Yeah. And that's the array that I was going to change. I think I should just begin with it and then fix the compile errors or something. What was my last change? Undo, redo. Okay, that won't compile. Git diff, the changes that I made are already significant, so I remove the whole thing. Let's just commit this even though it doesn't compile. That belonged to it. And now I pushed this and didn't push utils. So it won't compile, but it doesn't compile anyway, so we'll fix that later. Yeah, I was editing this. Yeah, let's change this part here. We're going to make I'm going to make this a utils array for sure. And that has a third template argument, which is an index. But it has a default. The default is simply an array index with the current type as the category. So it must be some unique thing, unique for the type of array that must accept this index. So well, we can't use symbol pointers. I mean, that has nothing to do with this. This is more variables. So we need to add a new category. Say shut up. Variables. No, got it. Unbelievable. Variables category. So. No, it must be the index type, not just the category, of course. Here's another example. Epsilon index type. Arg. And suddenly epsilon index type is no longer highlighted. What the hell? Okay, it is defined in my new header here, which is not part of that, so we have to fix that. I'm just adding all headers and source, or do we not have source at all? Repo base. Source. CXX, yeah, no headers here. Let's include the headers then as well. The notes there. Then I can do make C tags. And then edit the thing that I wanted to edit, which I don't know what it was. Probably this. So now we can jump to that, and it is simply an array index. Could have known that. Where's my category? Cat something. Variables category. So the index is the array index of the variables category. And I don't want to need this, because everywhere where you use this, and I'm converting here an enum clause to an int, in order to use it as an index in the standard array. But now using a utils array, so instead of an int, we have to use this type as the index type. So I would have to do a cast to this, which is not possible. Plus, I don't want to have to do it. I don't like casts at all. I don't like this function. I just want to be able to pass it directly. So instead of working with variables variable, at the point where we call toIndex, we must already have this type. And then we can just pass it directly to the array. So I'm going to remove the toIndex and then look where we use it for the variables thingy. So that would be here. So instead of toIndex, we want this E0. What? Plus I get value. Oh, okay, that's a sneaky way to run over all the epsilons. That is very nasty. Now, normally I would say you just run from E0 till over the indexes that represent the epsilons, and it could do that just in the loop. You know, you start at the first epsilon and you end at the last epsilon. But we also need the I here for the epsilons, which has a different index, namely the epsilon index type. So yeah, we do need a conversion. We need a conversion from the epsilon index type now to the variables index type, basically. And I think that the best way is then just to like literally type that here and have a function anyway. Right, let's convert it to epsilon index type. to variables index. Let's remove the type. So from epsilon index to variables index, because that's what I want to do. Now function doesn't exist yet, but we'll just add it later. Let's search further for to index. Here's another one, and that is doing the exact same thing. Okay, so this whole thing must be the same as what we have here. And then we have a to index here where we declare the symbol. Yeah. Well, that's a good one. I really need a name here. So apparently there must be a way to convert the name to my... Oh boy. I was going... Oh, wait a minute. I was going to remove the whole ename clause, right? So we don't have variables anymore. That's probably a better way to do that then. Let's say I want this to work still, but I don't want to use to index, like I said before. Maybe, I don't know. I mean, I'm just, you look at this line and I'm not really knowing how to do it. Well, basically I do, but I'm not writing C++. I'm more like making up what I would like this to be. And I think that maybe I'm wrong, but my mood is such that I think that I want to pass a variable here, whatever it is. And then at this point, I need a name of the variable. So that becomes variable name. And here we need the index. Shut up. Variable dot index. So because why like this? Because this looks like English. Yeah, this is what I want. So that means that this variable, whatever, I mean, it's a macro, it could be anything, but it's going to be something that is convertible to a struct, and the struct has both a name and an index. So we're going to have a struct. Let's add a struct, and I think I didn't use variable yet, so we can use variable. Oh, wait a minute, that's not going to work. This is a declaration. So this must be a literal string. Ah, boy, no, doesn't work. But the whole reason I want to declare it is so that the name exists. So, yeah. Okay, so I'm gonna use the name of this variable, the string that I'm gonna use for this variable, is equal to the name of the variable. So it's just variable here then. So it used to be a variable name, right? But the thing also has a type. So here it's just string. But it also exists. Is that possible? Because then it would get confused, of course. I mean, the compiler would get confused. It would say, if this thing exists, so I can put the dot index behind it, then it's not going to compile if I use it here as well. So there is no way around it than to have some kind of extra qualification here. What is the name? Put a namespace in front of it. So the variables must be in front of it. Otherwise it will never interpret this as a struct and that as a name. Maybe I should go back to name then, because now we have a variable's name. So that's, and it is like, yeah, literally string in this marker, the name of the variable. And then by doing variable's name, I get the object that gives me all the information, including the index. Yeah, no. Adding a const reference in this struct is bullshit, of course. Plus, I need my array index type. So you define that before the here. So let's give the thing a name. Using, yeah, thank you. Sometimes, so we can use that here then instead of that. And there is not much reason to not move this up. All. And then my struct, although this is just a macro, so I don't really have to have the variable defined already. The variables or variable. So I don't have to move it up actually, but no. Yeah, that's okay. Much better suggestion there. So now we have the index type that we need to use for variables here, because index is defined as such. But that means, of course, that variables double colon name must exist for every name. Where then variables used to be an enum clause, we are not going to use enum clause anymore. I'm going to use a namespace now. So we have a namespace variables. And that then must have, for each variable, declare variable, yes. But then declare variable is no longer like this. I think maybe I still want to need a, do I still need a count? I have to admit that this automatically increments every next element. But in my namespace, it's going to be a bit hard. Well, it is possible. It is possible, but it's insanely hard, I think. I can't even remember where I ever saw that. Yeah. Okay, let's cheat. I'm going to add an enum anyway, because well, it's variables enum then. Because of it is just easier to do the automatic incrementing that we need. I might as well steal the actual number from that. So this is then the variable enum, really. So now for each variable, what's my enum here? For each variable, we're going to have variable enum concatenated with a name. So just some long name that is not going to collide with the actual name, which we're going to define in the namespace here. Maybe I shouldn't make it an enum clause now I think about it, because the whole problem here is that in terms of collision, the reason I do this is because I don't want to get any collisions. But that's what the enum clause is for, isn't it? So we would do this, then don't even need this anymore. So now we have a comma-separated list of all variable names in this enum clause here, as we had before. But then it was called variables, and now it is called variables enum. And now I'm going to make, in the namespace, I'm going to define a struct, the struct variable. So the struct variable can be moved down, I guess. This more belongs to this thing here. So I want to have my declare. Let's put that here. It doesn't matter where you put it, but let's put it here. Declare that, and then we do use it. And then here, this one, we define this one, and then we use it. And this here is a namespace that must declare structs. So really, we have here a variable, yes. And the thing must have a name. But this is not quite it. Variable name. And then we need an index. So let's see. What I have is a variables enum name, which is an enum clause. And I have to convert that to a variables index. That is a stringified name, so that would work. I'm not even using it yet, but well, might as well be in there. So now the question is now how to convert this name here from the variables enum, which is just a comma-separated list of names here. So this is the type. And I want to convert it to the variables index, which is an utils array index. Now we have to begin looking at how the array index is being constructed or can be constructed. And it can only be constructed from an int. Yep. So you have to cast this thing to an int. That's it. Static cast int. That's allowed for an enum clause. And then it will try to construct the variable, which means that it just wants to try to convert the int to the variables index, which should work unless it is explicit. So I have to go back again. And it is explicit. So that would not work. There's no automatic conversion from int to array index. So we must explicitly construct the thing first. That would be this one. Huh? And now it should work. So now we have variable structs listed in this namespace here. So we can get the index now, and that index has the right type. So yeah, I think this works. And then there is a toString. Is that going to work? Variables is a namespace now, so that's not going to work. I want to pass the same thing probably as I want to pass to, God knows, I don't know. What am I passing to toString? Let's just compile it. No, wait a minute. Enum variable, switch variable. No, you know what? For now, let's pass a variable object. I mean, the thing is called variable, so maybe that makes sense. And then we can do switch. I don't even have to switch actually. I can just add case return. That's also a switch, but we know the name directly. To return the variable name. Can just return that directly. So this was kind of wasn't necessary anyway then, was it? Well, either you have to make a switch where you the AI case return does the same thing. It just does a stringify or whatever you pass. Or you can already do it here and then just store it in the struct. So I'm no longer needing that or using that. Let's have a look where it all fails now. You've only declared identify a number of variables. Yeah, maybe I just moved it down again. It didn't have to be here. So where's variables really used? Variables. Could put it in front of this. But. Doesn't really matter. I mean, it must be below this point, otherwise we don't have a number of variables. I'm going to put it there. Use of undeclared identifier of variables. It's all in the order. The order is not correct. Actually, it is not order. This was renamed to variables enum. Unknown type variables index. Did you mean variables enum? No, I didn't. Oh God, no that. I moved it too low. Okay, we'll move it up again. Must be in between these two. Semicolon of the top level something. Yeah, it's no longer. Wait a minute, did I do that? Yeah, I did. This must be semicolon, obviously. It's not comma separated anymore inside the namespace. Unknown type variables that you mean variable. Probably. No. Yeah, yeah, well, okay. There is a variable index here. No, no, I want to replace this whole thing. I want to replace it. We don't have an enum anymore. I replace this with my index class. Yeah. So this should now become auto variable. What does this do? This run over all the variables. So variables all. What? Really? Interesting, but no. No. We are running over variables. Variables. Oh yeah, no, it's good. Yeah, that's what I want. Wait a minute. Did it add this? No, bullshit. But okay, now we have an I begin. It's set for index begin, and then as long as unequal that, blah blah blah. So this is good. Now you don't want to do this. You want to do this. So variable's variable, and this variable is still now the index. And then we have a pointer to the realization of a symbol, and that must be passed a string. We had a toString, which also takes the index type. Well, yeah. No, it doesn't. It takes not the index type, it takes a variable. Variable cons reference. Where's my variables? Symbol cons reference. That is not the way. Yeah, if I have a for loop, then the only thing I can run over are arrays. And we have only one array. And that is the variables array, which only stores symbol cons pointers. So there's no way to get a name anymore. Unless my symbol stores the name. And it does, of course. So how do I create my symbol then? Declare symbol name here. I'm not passing a name here. How does it work? Symbolic symbol. The symbol itself has a name. Yeah. Okay, but those things. This is just storing a pointer. So at the moment that the variables, the thing in the variables is created, we're passing a name. I'm pretty sure. Yeah, but that's here. Exactly here. So I can't use that yet because this is where the symbol is being created. And then yes, I pass the name. But we don't have variables yet. I'm filling it. There is literally no way we can run over the. This is just not working. I have to run over all the enum values. But that's also not enough. Damn it, I need my switch back then. This is ridiculous. Or I can use another macro, of course. Well, that's also dirty. I don't want to use so many macros. I only really want to use a macro when you have to because you just need something like that, like a declaration. Want you have a macro for declare symbol and declare variable. Declare, and so all of them are declare. If they're declarations, then you really can't get around it. But in this case, yeah, okay, well, the only names that I make here are these stringifications here, I think. Where I really make them, or I have to add my toString switch thing back. Maybe I should do that. Maybe we should do that. Because this thing ends up in... No, then I need the literal name string. So they'll use probably UN typed, and it's not possible. We're also looping. So there's no way. I have to fix this, change this back to a switch. And then run over all the enum values. That is the only way. That it remains almost as dirty as it was. Damn it. Nou ja. Hello, Mitchell. I think I'm half an hour too late with that greeting, but This one, huh? My mouse is broken. Yeah, this, I mean, come on. Might as well use this, use the old code here. Damn it. Sometimes you have to think things over before you start coding, apparently. Of course, I feel that now this was a kind of a dead end. Well, the idea is that I get rid of this list here. So I can still continue and reevaluate if I can get rid of it still. Why? Why is it red? I'm pretty sure it's okay, but I don't like the red, so let's do it like this. Now a variable's only used only once, so I might as well do that here. And then it feels like that still feels like I want to loop over the index directly here. But and I believed copilot again, but that is not good. Static cost, variable index v. Yeah, what? No, nonsense. Sorry, that is good for an index. Oh, but it does work. Loop over all the indexes, and then I don't have v anymore. But we can. That's rather easy. just index get no get value. But I still have to get my toString back now. toString, the old toString. This now gets the variables enum. Variables enum. Where is that toString? Oh boy, I don't have it. Or did I do another push somewhere? Huh? That wasn't changed here at all. No, here it is. It is not committed yet, so I don't know why it went away. It's inside a struct. Strange. So this is the toString. This is stupid diff. But I must be in a diff. If I copy this and I lose it again because stupid git cake erases my clipboard. Yeah, it's here. Copy. toString variables variable. Okay, we have to add back add case return as well. Right. toString takes a variable enum. I'm having this double now. Why am I having it double? Variable index does not exist. Typo. Variables index. Use of undeclared identifier epsilon index to variable index. Blink blink. Oh, I never declared that one. We're not done yet, it seems. Yeah, 2 variables index, so that must be already declared then, which is here. So it has to be moved down, I'm afraid. I don't want it to move it down. How about I move this one up? So that's my type. Yeah, it's not good enough because the epsilon index is also not declared yet, is it? Actually it is, I think, maybe, yes. Type. No, that's just FA epsilon type, index type. Yeah, it's again pretty impressive. No. I think that variables enum must have been declared already, so it has to be moved down a little bit to below this point. Undeclared identifier FA, yeah, the and it is a template. A well overloaded square something with, well, yeah, array. So that thing only takes the index type. We are trying to pass what? From int. We're trying to pass an int. Yeah, that's not good. No. You've got to be kidding me, right? I and j, apps plus 4. I don't think my code is becoming better readable because of all of this. So what you really want to have here is something like blah is C0 till C3 inclusive. Then it would be readable. And I'm doing 0 till 3 because my macro declares C0 first, and then C1 and 2, and then C3. But yeah, and you know, I mean, not robust and stuff. So really you would have here C0 and then C3 mentioned, and then you still rely on the fact that C1 and C2 are declared in between those two, but it's a lot more reasonable, I think. Not even that likely to change in the future. But because it is a for loop, it's again not working with my namespace. That's only for if I just type it. Unless I can get from the C0 in my namespace the index type. So let's not be bothered with what the index type is, and I'm going to just use auto, and then I want to get my index type from C0, and then the question is, what would it get if I type C0 here? Well, nothing, because I have, I think, 2 C0s. One is in variables enum, and the other one is in the namespace variables. Now, I really hate running over my enums, because then I have to convert them again. That's just too dirty. So I want to be able to, I think, get an index somehow from these variables declared here. But yeah, then I need to do using variables, maybe using namespace variables, and then hope that we don't get collisions. Or I should put the variables here in front of it, of course. From variables, give me C0. But this is only going to work if now I can convert this C0 to index. So let's say index. I just want that to work. Damn it. Can we get it to work? Well, what is stored in variables? That was a namespace. And we are filling it with declare variable macro, which declares a variable, which is a struct, which contains an index. And it's public. I can just remove the parentheses, and it's working. And then here we can do the same thing. Now j equals, there must be an auto then, because it's an index type. So it's equals I, and then it must be less than or equal. That's kind of scary, because now it is an array index type. Array index. Oh, it does have a less than or equal. So I could use that. Slightly more logical would be to use unequal, I think, though. As you would do for iterators. But if I use unequal, then yeah, I have to use a for here, which is then 1 past the C3. That which would be epsilon 0, but we don't know that. So let's not do that. Let's use less than or equal for that reason. Well, I use that here as well already. But now I get a problem here, because what the hell is this doing? Oh no, it's just 2 or 1, it's no problem. I can compare array indexes. And we can pass array indexes to variables, obviously, that was the whole point. And then we have an assert that uses I plus j minus 1. No. So I really have to convert these things to integers, I think. At this point in. Now, here's another variables. I think that was the only other loop. Below we don't use variables anymore. No. So to fix this as well. No, that is exactly the same thing. So you can just copy that. C0 till C3, and then I till also the same thing. Same thing. That works. But here we have a K, or rather an EPS plus 4. What does EPS plus 4 mean? Oh, the plus 4 is to skip the C0. So what I really want to do here is run over all the epsilons. Epsilon is the epsilon index. Okay, give me epsilon index. Yeah. I think there's these things here. 0, 1, 3, 5, 6, 7, 9. But I want them as index. As variable index, really. I think it's not unlogical to want to type the 0 till 9 here, because that's what we see in the comment as well. So I have to convert this indeed to, afterwards, to a variable index. Hey, we have this epsilon index to variable index. So I could use that if I just first convert this to an epsilon index, which of course you can do, because that's just the cost. That's the epsilon index type. So you can cast it to an epsilon index type. Wait a minute, an epsilon index type is also an array type, which can be constructed from an explicitly constructed from an int. No problem there. So my epsilon index can be converted to an an epsilon index type. How do we do that? I just jump here. Don't you dare becoming red. No, this one is good. So this is an int, and we can construct an array index from an int. And then we have this function to convert that to a variable index type, which it should be. And then if I would not do this and just have something else here, then this won't even compile, because variables demands that it is a variable index type. Isn't that cool? If everything was an int, I could accidentally pass k here, or it has to be k plus 4, but this is like 4 times more characters, but it's robust. It won't compile unless you do the right thing. For example, say I forgot to remove the plus 4 here. Don't tell me that will compile. Please don't compile. Pretty sure it has to do with plus array index plus n. But does it say where the problem is? It's the only Newton epsilons thing that we have. Looks like it's erroring out here. What? Is it giving the error on the wrong line, or? Oh, wait a minute. Yeah, I forgot to do the get value stuff. So we didn't get there yet. Get value. Get value. Explicitly convert them to an int. Yeah, the kind of, if you know what you're doing, you're allowed to get value, and you're allowed to use the integer values if you really want to. Damn it, it compiles. Well, maybe I had a reason for that, but yeah, okay. So you can add an integer to an array index apparently. No, let's see if it still does something. It still does the same thing as before. Yeah, that looks exactly the same as before. Okay, I'm just kidding. No, actually it does look exactly the same as before, because it's also a whole page. And I recognize this 117. Must be working. But yeah. Wait a minute. The real problem here was, or the goal here was to get rid of these things. I would say it would be nice if I don't have to use the I there. We have E0 till E20. Well, at least we have them in the namespace, or we have them as an enum. I can pick. What am I using anyway? I mean, like, am I using anywhere below this point E followed by some digits? Maybe more than one digit. And then followed by anything except an I. So lame. No, apparently not. So we are only using the I versions of the epsilons anyway. So we just remove all of this. And then do a using namespace, I mean, or using the enum class, both will work. And then is the question, can I convert that then to 0 till 20? Can I convert it to epsilon index type rather? I think so. Let's use the namespace. So I'm going to do using namespace variables. And now I can use, say, E1. That would then be variables E1. And that namespace is storing these structs. So now I have a variables index. So if we add the opposite of this, then we can also go from the variables index to the epsilon index. Just add that here. So go way the other way around. Wow. Let's check it though. Variables index to epsilon index, so variable index I, return floating point overrun, blah 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 blah. I get value minus that. It's brilliant. Yeah. Impressed. Yeah, impressed. Okay. And what were we changing then? I forgot. I really forgot. I can just do Control T. So I'm going to strip the I off. We don't need these anymore. We're going to use the epsilons that are declared here. Oh, wait a minute. That's something else. No. These are symbols. Oh shit. The symbols are also... The symbols exist. They have the same name. Can't do a using namespace. Damn it. So I do this and it's ambiguous. Then we don't know if you name would you sorry, if you mean the symbol declared here or if you mean the variable struct here. Now I want to declare the symbols. I need to declare the symbols. I'm not using epsilon, so maybe I don't want to use this. I mean, I want to use for each variable, but I don't want to do this for the epsilons. Let's do that. So we're going to split this in for each variable and for each epsilon. For each epsilon top. And then here we remove the epsilons. So these are my variables now, and these are my epsilons. And then the question is, do we want to have all the variables here? Well, actually, probably not. Because you had to use this stupid offset thing. On the other hand, yeah, no, probably not. Probably I should have just, probably should separate them all the way, if you get what I mean. AKA make a separate array for variables and for epsilons. And then the variables named the variable index, and the epsilons takes an epsilon index. Simple as that. It's just, that's how it should have. That's how we should have done it. I think I'm going to do that though, but let's for now not do that immediately. And make this compile the way it is now, and then I'll split it up. So the only thing that changed now is that x is no longer, wait, that, oof, it's worse than that, isn't it? Well, maybe I should do this one, epsilon's at the bottom. Okay, so the only thing that changed is that x is no longer at the bottom. X is now, well, in the middle. But count is at the bottom, so we can still make that work. Namespace variables, yeah, really? Well, yeah, I hate to do this, but I think that should work. I thought I was using the fact that x was lost somewhere. So there must have been a for loop, I guess, which uses x somewhere. Not really, not like that anyway. I don't know. I'm pretty sure though. But, no, I guess the program will horribly fail if that is the case. So let's just try it out. I think I'm missing a comma. No, I'm not. Oh yeah, that would be missing. Yep. Okay, so I'm going to strip the I off here, and here, and here, and here, and here, and here, and everywhere. In fact, every time we construct an FA where we have an I that is followed by a brace, that should be the last one. Oh no, 16 is the last. And then the constructor of FA is now taking something that it doesn't know anything about because it's an external class. No. Yeah. But it does know about it, because he does know about it. This class knows everything about epsilon index types. Wait a minute, I'm not passing an epsilon index type anymore. No, 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 no. See, this is problematic. I'm now passing this weird structure called variable. Well, it's an epsilon, really. See, the whole everything epsilon should be part of the class, not a part of this. That's why you have to split it up, and I can move everything epsilon to the class template, to the template class. Yeah. I think I'm going to stop now in the middle, because it doesn't compile now, so it's a good moment to go to bed. And then I'll fix it probably off stream tomorrow, because it's just getting late. Let's play a game of chess. Yes, blitz. I dropped below 1900 again. So horrible. That's English. Let's play this, because I'm just gonna copy my opponent to confuse him. Okay, I won't. Oh, I forgot. For some reason, I was thinking that the bishop was looking against these pawns. Why? Should I just give up? Probably should give up. Okay, how can I still win this? Really? I wanted to go here. I wanted to go here, I mean. Doesn't matter, I guess. That's what I wanted. Shit. I can still go here. Maybe I should stop playing immediately. No, I'm gonna play one more. He did not see that I gave away my queen though. But yeah, I did, so not having my day. Yeah, shall I say about it? I want to sacrifice here. It's not really working, is it? Can pin the knight and then take it again, and then this knight goes there, defending it. And then what do I have? Except for one piece less, for 2 pawns. Shall I do it anyway? can also take here. Take take the queen for free then. Take my queen though. It still has a pawn. So nothing is working. Have to go away. I'm losing this pawn now. Tactical build up. Yeah, I just lose a pawn. Shit. Well, I'm threatening to take a queen with check. That is pretty forcible. Is that good? Oh my motherfucker, I'm doing it again. That's the same error as in the beginning. Just give away full rook. Oh my god. Pretty damn depressing. Depressing. That's what it is. Could have won my knight, but he didn't want to. I'm going for the stalemate. Probably not that easy though. Oh, I do that? No, it doesn't matter. I can't even stop the thing anymore. Wait a minute. He walks, you go here, he walks again, and then I'm just too late. Yeah, I'm too late anyhow. Still have to escape here, unfortunately. As if this guy is not going to give check, 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 check. Oh, it's not giving check. Surprised. Yay, stalemate, yay. Ah. Almost. If he had moved a knight or something, or there was also mate. If he had moved a pawn to get the second queen. Yeah, I'm gonna quit. I'm gonna quit playing chess, I think.